All right, in this section of the course, it's time for us to start something completely different. So you can temporarily forget everything you've learned about physics so far, and we're basically going to reset back to day one and learn a completely different approach to thinking about physics, which was developed in, different century by different people. And at the end of the day, it amounts to the same thing. We're not contradicting anything that we learned earlier in the course, but it's such a different viewpoint of why things are happening in physics that it's often could be much easier to think about a lot of problems this way than the way you've been taught so far. So let me start at the beginning. This section is going to be all about something that's known as energy. That is the big word at the top of everything. So, to start out with, imagine that everything in the world has some stuff called energy. And this fundamental question of the course is why do things move the way that they do? And our basic answer to that question here is going to be that things move the way that they do because of how much energy they have and how they are exchanging energy with other objects. So objects are trading energy amongst themselves, passing energy back and forth, and energy is able to transform in various ways that we will be learning about. So let me start out by kind of telling you about some types of energy so that you can put your finger on this a little bit better. We're going to be talking in this course about mechanical energy mainly. So mechanical energy comes in two main categories. One is called kinetic energy and one is called potential energy. So let me introduce what these two ideas are, first of all. Kinetic energy is pretty self-explanatory, pretty easy to understand. It's the energy associated with motion. So a moving object has more energy than a stationary object. The more energy you dump into the object, it starts to go faster and faster. So that's pretty self-explanatory and pretty easy to understand. We're going to use the variable capital K to represent kinetic energy in this course. By the way, for these energy things in the algebra, there's not like a universal standard actually of what variables people use. So you might see some different variables if you're looking things up in other sources, but we're going to use capital K for this course. I'm not going to worry about the math yet of how you might go about calculating kinetic energy or anything like that. Let's worry about the math later. So kinetic energy is the energy associated with motion. Potential energy, and now for this one, we don't want to use P because we already used P for momentum. So for potential energy, we're going to use U. Don't ask me why people use U, but U is a common choice, capital U. And potential energy is a little bit harder to define. This is an umbrella term, basically, a huge category of different types of energy. It doesn't refer to one specific effect. It's really a catch-all for a lot of different things, so it's a little bit harder to define. Let me try to define it and at least give you some idea of where the name comes from. It basically describes the energy associated with an object's potential to gain motion later. So, for instance, a very simple example that we'll use as our main example to start out with is if you take an object and if you lift it up and raise it up off the floor, it now has the potential to fall back down. And if you release it, it will fall. So by lifting it up, you've given it the potential to fall later. So that has some energy associated with it. But that's not the only type of potential energy. You can have a potential energy for almost any force that we learned about. So like, for instance, there's a potential energy associated with a spring. If you compress the spring or stretch the spring, once you release it, it's going to snap back to its rest length. So that gives you a potential also, because stretching out the spring means that it has the potential to snap you back to the rest length and give you that motion later on as well. So those are our two main categories. Maybe I'll end this video here and tell you why this is significant in the next video.